In example 9, we saw that there were no real solutions to the equation x squared plus 1 equals 0. But we ran into this problem a while ago. Before we invented negative numbers, we could not solve x plus 1 equals 0. This was the whole reason why we invented new numbers, so that we would be able to solve it. And before we invented fractions, we couldn't solve 2x equals 1. Again, this is why we invented those new numbers, so we could solve it. Now, we cannot solve x squared plus 1 equals 0. So what do? We need to invent new numbers, so we can solve it. Let's try to solve this without the quadratic formula. We'll start by subtracting 1 from both sides. This gives us x squared equals negative 1. Now, we can take the square root of both sides. This gives us the square root of x squared equals the square root of negative 1. And on the left, the square root of x squared is the absolute value of x. This means that x has to either be plus or minus the square root of negative 1. But the square root of negative 1 is not a number. That was the whole problem. Well, it's not a number yet. The new number we invent, we're going to call I, and we define it as the square root of negative 1. With this new number, we can now solve the equation x squared plus 1 equals 0. Its solutions are x equals plus or minus I, our new number. Now let's look at another example. Let's find the solutions to x squared plus 4 equals 0. Like before, we'll start by subtracting 4 from each side to get x squared plus 4 minus 4 equals 0 minus 4, which is negative 4. And on the left side, 4 minus 4 is just 0, so we just have x squared. And the next step to solve x squared equals negative 4 is that we need to take the square root. This gives us the square root of x squared equals the square root of negative 4, where the square root of x squared is the absolute value of x. Now, how do we take the square root of negative 4? Do we need another new number? Here, we don't. We can get away with writing this in terms of the number I, which we already invented, and we don't need any other new numbers. To do this, we realize that we can write negative 4 as 4 times negative 1. And then we can split this square root up as the square root of 4 times the square root of negative 1. The square root of 4 is just 2, and the square root of negative 1 is I, so what we have is 2 times I. And since the absolute value of x equals 2 times I, we get that the solutions are x equals plus or minus 2i. In other words, 2i and negative 2i. So even without inventing another new number, we were able to solve this using our number I. Now let's look at another example. Here, we'll find the solutions to x squared plus 3 equals 0. Starting the same way as the other ones, we subtract 3 from each side to get x squared plus 3 minus 3 equals 0 minus 3, which is negative 3. While on the left, we have x squared plus 3 minus 3, which is just x squared. And now to solve x squared equals negative 3, we need to take the square root of each side, giving the square root of x squared equals the square root of negative 3. Where the square root of x squared is the absolute value of x, and the square root of negative 3 we can break up as the square root of 3 times negative 1. Like in the above example, we can split up the square root of 3 times negative 1 as the square root of 3 times the square root of negative 1. And the square root of 3 we can't simplify, we just need to leave as the square root of 3, but the square root of negative 1 is I. So what we have is the square root of 3 times I. It's important to note here that I is not under the square root in this. And now to finish our problem, since the absolute value of x is the square root of 3 times I, we get that the solutions are x equals plus or minus the square root of 3 times I, which is the square root of 3i and negative the square root of 3i. So now using this new number I, we can solve equations that we could not have only using real numbers.